Okay, guys. Remember we worked with a condition of our exponents, just dealing with exponents in general, working with the laws and so forth, the rules that you need to understand. There is a part that we refer to as the exponential equations. All right, the moment you think about equation, you think about solving for something, solving for an unknown value. That is what you think of. The moment you just think of the word equation, solve for, you are thinking of solving for something. For what? Is it for X? Is it for M? Is it for Y? Is it for whatever letter, whatever variable that you have? That's an equation. So we can have that same equation, but under exponents, all right? Remember, we are under exponents, so we refer to them as the exponential equations. Okay, meaning to say, under the layout of our exponents, whereby we can have a condition of a number raised to a certain exponent that we do not know. We know that 2 can be raised to the exponent of 4. You multiply that number, you get a 16. Remember, n times, that is 4 times 2 times 2 times 2 times 2. 2 times 2, which is 4. 4 times 2, which is 8. 8 times 2, which is 16. This is the same situation that we are now having, but they remove this and they want you to calculate that the same number that gave us F16, they want you to find it. So it's the same thing like what I'm trying to explain. They might give us 3 to the exponent of x equal to 27. They want us to calculate x, to find x. These are what we refer to as exponential equations. So how do we solve such type of questions that we might be given of this nature? Okay, let's consider a being raised to the exponent of m. Okay, the same a also being raised to a certain exponent of n. But considering that this is a and this is a, there is no way that we are going to see a number like 2 to the exponent of 3. Okay, being also written as 2 this side, being raised to a different exponent, which is not 3. There's no way, because we are going to have different answers. So we are going to see that it must be also be raised to the exponent of 3 to be equal to this. It must also be raised to the exponent of 3. So there is no way that these two can be equal unless the exponents are also equal. That is where we can say these two are equal, because already these two, we can see that they are the same. So it follows that m must be equal to n. So it follows that if these two are the same, therefore m is going to be equal to n. Okay, so what can we do with this situation? It can help us to solve a lot of equations. Okay, 3 to the exponent of x is equal to 9. Okay, can I write this 9? Because what I want is to make sure that these bases are the same. So can I write this 9 in simplest form in terms of 3? All right, so I can do that. 3 to the exponent of x is same as, remember, 9 is same as 3 to the exponent of 2. So here you already have a clue about what base are you going to consider. You already know I'm going to consider the one that is already in simplest form, a prime number here, which is 3. So if you do not know the number that you're going to use, you can use your calculator to test 3 to the exponent of a 1. You get a 3, not a 9. You move on 3 to the exponent of a 2. You get what? A 9. Meaning to say 9 can be written as 3 to the exponent of a 2. Once you do that, you can see that you are now in the same base. You are now referring to the same number, which is 3 here. So if it is that so, Therefore, what are you going to do? You are going to equate. Let me just highlight a little bit so that you can be together here. This is the part that we are referring. These two are the same. So if they are the same, guys, there is no way. It simply means that therefore x must be equal to 2. So therefore x is going to be equal to 2. All right. So that is what we are simply referring to here. Okay, let us consider to say I was given 5 to the exponent of x being equal to 1. Okay. What? All right. Sorry for that. Okay. Sorry for that. We wanted to have it this way. I don't know if it is clear. Is it clear? Okay, maybe. I don't know what is happening. Is it my network or what? Okay, this way. Now, let us think of 5. Let us think of 5. We have a 5, here we've got a 1. I think it's clear, this one, okay? We have a 5, and here we have a 1. The question is, we are supposed to have same numbers here, the bases. Already 5 is a prime number. So there's no way I can write it as a 1, as this one. But I can go back to this one. I can write it as this number, which is 5. I can write this one as a number, which is 5. But it must be to the exponent of what? So that I get the same one that I'm seeing here, because I have to write it in terms of 5, because 5 is a prime number and it's already in simplest form. So which exponent am I going to use here? Is it going to be 1? Is it going to be 2? Is it going to be 3? No. So this one must be a 0. Remember, any number, when raised to the exponent of a 0, it gives us a 1. So 5, when being raised to the exponent of a 0, it gives us a 1. So meaning to say this one, I can write it as a number in base of 5 because I want this to be the same, but now to the exponent of a 0. Once you can do that, guys, just like what we saw here, so that if these two are the same, what does it mean? It means x must be equal to 0. So in that nature, therefore x is equal to 0. Okay? So we can even take down these our values that we got here. Substitute them back and see. If we put a 2 here, are we going to get a 9, which is true? If we take this value, which is a 0, if we put it here, are we going to get a 1? 5 to the exponent of a 0, it's a 1, which is true. So it means this value of x is true. Okay, so these are the questions that they are just trying to portray here. So let us see, we are asked to solve the following equations. So it is you who is supposed to know that this is an exponential equation. They don't tell you that this is an exponential equation. You need to know. So as long as we deal with this exponent, the base to the exponent of a certain number, you know that you are dealing with what? Exponential equations. Okay. As you can see, we already talked about number 1, 2 to the exponent of x being equal to 1. Remember, I said we can write 1 as any number to the exponent of a 0. So it means we're going to have 2 to the exponent of x as 2 to the exponent of 0. The purpose is to make sure that these two are the same. Once these two are the same, therefore it means, therefore, our x is going to be what? Our x is going to be equal to 0, since these two are the same. Okay, so you can just get rid of that. So you're going to have our x being equal to 0. Okay, and let us move on to the other question. Number 3, we've got number 2, sorry, we've got 3 to the exponent of x, which is equal to 3. So remember that any number can be written as it is to the exponent of 1. This one is not to the exponent of 0, no, because 3 to the exponent of a 0, it gives us a 1. But 3 to the exponent of a 1, it gives us a 3, okay? 3 to the exponent of a 2, it gives us a 9, and so on and so on. So this one, if the exponent is not written here, you put a 1. So that's 3 to the exponent of x is equal to 3 to the exponent of a 1. So the moment, like I said, that the moment you see that your bases are the same, we can see that we've got 3 here. We also have a 3 here. So what are we going to do in that situation? You are going to equate our exponents. They are the same also. So x will be equal to 1. Okay, that is how we can have this. Same as number 3. Okay, on number 3, we've got same condition that we can apply. 3 to the exponent of x is equal to 27. So 27, this number, and base of 3 is the same as 3 to the exponent of 3. All right, 3 to the exponent of 2 is 9. To the exponent of 3 is 27. You can also prove it on your calculator. Okay, so meaning to say, in place of 3 to the x, in place of 27, this one, I'm going to write it as what? 3 to the exponent of a 3. So we can see that we are back to the condition that our bases here are the same. We've got 3, we've got 3. So what are we going to do if these are the same? We are going to equate our exponents. So our x must be equal to 3. So this is the answer that you're supposed to get there. So if you put here a 3, you are going to get the same answer. If we put a 3 here, 3 to the exponent of 3 is what? Is 27. All right. 4 to the exponent of x, on number 4, we are given 4 to the exponent of x, which is equal to 16. On this one, I've got 2 ways to answer it, okay? I can write this 16 as a number in base of 4, which is very, very possible because understand 4 times 4 is 16. So it means 16 is equal to 4 squared. So if it means 16 is equal to 4 squared, that means here I'm going to have 4 to the exponent of x, which is equal to 4 to the exponent of 2. Remember, what I just want here is to make sure that these two here are the same. I've got 4, I've got 4. So I can equate my exponents in this case, which is x must be equal to 3, must be equal to 2, sorry. So meaning to say, therefore, our x is going to be equal to 2. Okay, what if I wanted to have it this way? It's this, besides of writing it as a number in 4. What if I write in simplest form and also this one in simplest form? What was going to be the answer? All right. 4 to the exponent of x is equal to 16. We know that this 4 can be written in base of 2 also as 2 to the exponent of 2. So it's going to be 2 to the exponent of 2, but we are multiplying with x. Remember from our introduction, guys, we said 2 to the exponent of 2 to the exponent of x like this. You just have to multiply. So this will give us 2 to the exponent of what? Of 2x. An exponent and an exponent, okay? Which is equal to 16 as a number in base of 2. That is 2 to the exponent of a 4. That is our 16. So meaning to say we have again the same situation, but this time the number is not 4, it's 2. This one, 2, and these two are the same. So what do we do if that is the condition? We simply equate our exponents together, which is 2x and what? And 4. So it follows that 2x must be equal to 4 also. So this time you are multiplying 2x, an equation. There's a 2 which is multiplying. How do you remove these 2 that is multiplying? You divide by 2, you divide by 2 both sides. So this will cancel. So your x must be equal to 4 divided by 2, which is a 2. Or simply divide by 2 here by 2, you're going to obtain a 2, which is the same answer as this one that we obtained here, that x must be equal to what? A 2. So as long these bases are the same, as long these numbers are the same, does not matter which way are you taking your answer to. As long you understand that those two are the same, you can provide your solutions in any way. And as you can see, you obtain the same answer. So that was the condition of our question number 4. Let us check what we have on question number 7. All right, let me just remove these ones. We are done on these ones. All right. So let us check what we have on question number 5 in this case, sorry, that's 7 to the exponent of 4x is equal to 49. Okay, so this is equal to 49. So considering this, we are going to see that we can simplify this, okay, knowing that 49 can be written as a number in base of 7. Remember, 7 to the exponent of 0 is 1. To the exponent of 1, it's a 7. To the exponent of 2, it's a 49 from our calculator, and so on and so on. So at 49, it's 7 to the exponent of a 2. So this was going to be 7 to the exponent of 4x, which is equal to 7 to the exponent of 2. So we can write this because already this 7 is a prime number, so there's no way we can write it in simplest form, okay? But the moment we see that this happening, just like the previous case, that this base and this also base here are the same, do not hesitate to equate your exponents, these two. They are now equal. So it follows that therefore 4x must be equal to 2. So if 4x is equal to 2, what about the value of x? I divide here because I'm multiplying, so I divide by 4, divide by 4. So thus we are going to obtain the value of x, which is 2 over 4. So 2 over 4 can be written, you can divide by 2. 2 into 2, that is a 1. 2 into 4, that is a 2. Or you can just use your calculator to simplify that. You're going to see that your x is going to be 1 over 2 or 0.5. So that is the idea, guys. I just hope we are together on this part. All right, so that was our question number 5. All right, if you check on question number 6, they are just trying to confuse us a little bit here. What are they trying to do? Okay. We are given in this case 3 times 3 to the exponent of x, which is equal to 243. Okay, so the question is, because already we can see a hint, it's already there, like a clue is already there. You already have a clue of the base that you're gonna use, which is 3. 3 is a prime number. So if a number is a prime number, it is already in simplest form. Remember, a prime number is only divisible by 1 and itself. So if you see a prime number like that, it's an advantage for you because you already have a clue that there is no other number that must be in simplest form except for what? Except for 3. That is the one in simplest form. So what do? You try to raise this 3, this number here in terms of 3. You are going to try to raise this in terms of 3. All right, until you get 243. If you do not know it by head, this is what you're going to do because already you have a clue that I'm working with the base of what? With the base of 3. So you can try 3 to the exponent of 2, you get a 9, which is not 243. 3 to the exponent of 3, we get a 27, which is not 243. 3 to the exponent of 4, we get 81, which is not 243. 3 to the exponent of a 5, we get 243. So meaning to say that we have a clue that we have the best to use, but the only thing that we do not know is the power, the exponent, that you are going to use there to affect to get 243. So now we know that is 3 to the exponent of what? Of a 5. So we are going to write this as 3 to the exponent of a 5. All right. Already here on the left-hand side, these are already in simplest form. It's 3 and 3, but it's not a single number or a single term. So what do? I'm back now to the laws of our exponents. If we are multiplying a condition of the bases that are the same, right? That are the same, I'm going to add the exponents. So here I've got 1 and here I've got x. So I'm going to add 1 plus x because these two numbers are the same. I'm now back to the laws of multiplication, guys. Remember from our multiplication from the introduction, all right? So this will give us 3 to the exponent of 1 plus x, like this. Once you are at this stage and you are working with an equation, this number, your base, and this number, your base, are the same. What do? Equate your exponents, okay? So therefore, it follows 1 plus x must be equal to 5. So you're going to have 1 plus x being equal to 5. So to find x here, I can simply transpose this one because it is being added. So I can take it to the other side, it becomes a negative. So x is already a positive here. It is going to be 5. 1 to that side, it will be a -1. So we obtain the value of x, which is going to be a 4. So this is the value of x, which satisfies this. Okay, let me prove it this way. I can take my calculator, press in the values that I'm given. All right, the first one is 3 times 3 to the exponent of x. So it's 3 to the exponent of x. We said our x is 4. So you're going to put a 4 there. You get 243, which is the same number that you get 243. So you can actually prove that your answer is correct by substituting the value of x that you obtain into the equation that you're given and see if it gives you exactly what you have on the other side of the equation. All right, let us consider number 7. Number 7, we've got the same situation or a same scenario, but this one, they already simplified this for us. If you check, they have already simplified this for us. 2 to the exponent of 3x minus 1 is equal to 64. They have already simplified. This is what we had to do in the first. We had to combine. Already here, they combined for us already here on number 7. All right, they already combined this for us. We already have this as a single term. What we just need is to rewrite the 64 in simplest form. So already we've got a clue because 2 is a prime number. This number here is a prime number. So if it is a prime number, it is in simplest form. So what you're going to do is to write this 64 as 2, but raised to a certain exponent. If you know it by head, that's 2 to the exponent of 6, it gives us 64. It's an advantage. But if you do not know that, do not hesitate to use your calculator. Like I said, you know that my simplest number that I'm going to use is 2. So I have to test 2 to the exponent of 3, to the exponent of 4, to the exponent of 5, and so on and so on. And so, see, until we get a number which gives us what? A 64, which is at what? At 6. So this 64 that we see here is same as 2 to the exponent of a 6. So we are going to write it as 2 to the exponent of a 6 in that case. So 2 to the exponent of 3x minus 1 must be equal to 2 to the exponent of 6. We have now a condition that these two bases are the same. It's an equation that we have. So there is no way that these two can be equal and these two on top are different. There is no way. It can't be like that. Once these two are the same, automatically these two must be equal. That is the law. That is the whole part of this class. Okay, this is equal to 6. So 3x we can transpose. Remember your equations, guys. Transpose -1. If it jumps the equal sign, it gets a positive sign. Okay, once a number jumps the sign, it changes its sign. If it was a plus, it becomes a minus. This one was a minus. Once it crosses the equal sign, it jumps the equal sign, it becomes a positive. Okay, so 3x must be equal to 6 plus 1, which is a 7. So to find x, simply divide. Okay, all right, so that's our x. Is this will cancel, is going to be 7 over 3. So this is the value of x that was going to satisfy our equation, the one that we are given there. This was the value of x that was going to satisfy whatever that we are given on this part. So like I said, you have to be very, very careful on your simplification, okay? You have to be very, very careful. All right, like I said, guys, I cannot answer all of these questions, but I want you to try as much as you can to attempt these questions. So sometimes they might give you even a number that is multiplying. All right, this one is direct, guys. Okay. Also on this one, let's go back to number 6 again. Okay, I want to explain another way. 3 times 3 to the exponent of x is equal to 243. Okay, remember the last one we said we can just work with this part, write it as a number to the exponent of what? As a number in base of 3. Then we combine these two because they can be combined together. Okay, but it follows that you can also solve it this way because remember, this is a multiplication here. So what you can do to avoid unnecessary big values, you can divide by 3 both sides, okay? You can simply divide, because you're multiplying here, you can divide by 3, you can divide by 3, okay? That will be 3 to the exponent of x is equal to, you divide this one, okay? So it's gonna be 243, let us divide together and see what you're going to have. 243 divided by 3 or over 3, okay? Or you can write it this way, 243 over 3 like this, which gives us 81. Now we are back to say, can we write this 81 as a number in base of 3? All right, is it possible to write this 81? Yes, it's possible. It's 3 to the exponent of what? Of 4. Or we can try it, okay? 3 to the exponent of 3, it gives us 27. But 3 to the exponent of a 4, it gives us what? 81. So we can see that it's truly one and the same answer that you're going to get because here we consider that the bases are the same. So we are simply going to equate our exponents. So therefore, our x is going to be equal to 4, which is one and the same answer that we got from our last calculation that we did. So you can even play it that way. But yeah, sometimes you can just do that. I want us to consider that type of a calculation that I'm just using right now. You consider on number 12, you can consider that 8 to the exponent of x is multiplied by 2 is equal to 128. So considering this law, I mean this way of calculating that I just talked about right now, you can divide by 2 because you're multiplying here. So you can divide by 2, this side by 2 also. So this will cancel. You remain with 8 to the exponent of x, which is equal to here. You obtain also a single number because you're multiplying, you're dividing a number to a number. So that's 128 over 2, okay? Which is going to give us 64. All right. It's up to you now to write your 8 as a number in simplest form in terms of 2, or to just write this 64 as a number in terms of 8, because we know that 64 is same as 8 to the exponent of 2. So you can write it that way. Yes, you could have from this stage changed your 8 to be written in terms of 2. 2 to the exponent of 3, then you multiply by x, which is going to be 3x, equal to 64 in base of 2, which is 2 to the exponent of 6. Once the bases are the same, that is what is important. You equate your exponents. So 3x was going to be equal to 6. You divide by 3, we divide by 3. So that's our x was going to be equal to 2. Okay? Which is the same thing that we see here. The base of 8, base of 8. So x is going to be equal to 2, which is the same answer. So the simplification of exponential equations, like I always say, most of these calculations, they are in your hands. The way that you simplify is in your hands. Try to work in a way that you understand the most, okay? Perfect on the ways that you understand the most. If you've got something that is easier, it's fine. Introduce that to something that is easier, work on it until you perfect it. Because in most cases, those easy questions are the ones that tend to be difficult in answering, but just easy in looking into the question. But when you try to answer it, it becomes more challenging. So I want us to work on those questions, revise as much as we can. All right, let us consider this last part here. Just going to consider this last question. There we are given 3 multiply, that's number 19, 3 into 1 over 3 to the exponent of x minus 1 equal to 1 over 3 like this. All right. In this situation, we can see that it's true. We already have what we can see here. The 1 over 3, we already have the 1 over 3 here. This one is not going to work. So what do we do? Because there's a number that is 3. All right. Remember I said you can divide that number if you want, or you combine on the other side. Is up to you. So the easier part that we can just do here, let's divide by 3. If I divide here by 3, I divide here by 3. What am I going to remain with? 1 over 3 to the exponent of x minus 1, which is equal to, I have to divide this also by 3. So there I can just use my calculator because of it's something that is direct, okay, that we can just apply. 1 over 3 like this, 1 over 3. Then you're going to close your bracket, you divide by 3 like this. So this will give you 1 over 9. Okay. Which is not 1 over 3. It's now different. We no longer have the 1 over 3 because of just these 3 that we had. And also it did not, we couldn't allow, or we couldn't be able to equate this because of the number 3. Now we have removed this 3. Again, it is not allowing us to equate anything because these two numbers, they are now different. This is 1 over 3. This is 1 over 9. So we cannot write it direct as what we see. But what can we do? Is there are two ways. Which either we're going to write as positive exponents, or you can write this as 1 over 3. This one. We can write it as 1 over 3. But being raised to the exponent of what? Of 2. Remember, 1 to the exponent of 2, get a 1. 1 times 1, which is 1. 3 to the exponent of 2, which is 3 times 3, which is a 9. So I can write this as 1 over 3 like this to the exponent of x minus 1 equal to 1 over 9, which I can just write as what? As 1 over 3 to the exponent of 2. They're the same. Just one and the same thing. As long I see this and this being the same, as long these two are the same, what am I going to do? I'm going to simply equate because I can see that this whole part and this whole part that we see here are the same. So I'm going to equate now. X minus 1, all right, let's put it this way. Let us just continue this one. So it's going to be x minus 1 is equal to 2. So what do I do now? Transpose the negative 1 to this side. It becomes a positive. So x will be 2 plus 1, which is a 3. Okay, or you can just add direct. The x will be a 3. Okay, so that's it. If we take this value of x, let us take this into the calculator. Just going to prove direct on the calculator. Okay, this was our question here. I'm just going to put this. Remember, our x is 3. So I'm just going to put it direct on the calculator here. If x is equal to 3, we just want to check if this is going to give us 1 over 3. Okay, if x is 3, let us put 3 here. So on your calculator, let us prove this. Let us have our calculator here. So you're going to have 3. This one is 3 into, open a bracket, all right, 1 over 3. So you're going to have 1 over 3 like this. Okay, close the bracket. X minus 1, or x, we said our x is 3. So you must have an exponent there. 3 minus 1 like this. We're going to get 1 over 3, which is same as 1 over 3 here. So this is what I want you to do. I want you to work these questions. Every question, calculate for the value of x. Whatever value of x that you obtain, take it in your calculator, okay? Plug in your values and see if you are obtaining what is on the other side of the equation. If you substitute your x here, you must get 1 over 16. If you substitute your x here, you must get 1 over 25. If you substitute your x here, you must get 162. If you are not getting that, that question is wrong. So let me know on those questions that are like that, that you are not getting those answers, because this is how you can prove, because you are working alone, you do not have anyone to ask. So you can prove by that. You substitute your x here, If you do not get 128, it means that value of your x is wrong. So if it is wrong, let me know so that I can work that question again together with you guys. All right, so for the meantime, let us continue to revise as much as we can, preparing ourselves, working with more exercises, working with more question papers, and stay tuned for more question papers that we're going to have, because we shall work with more question papers, preparing yourselves for these exams that will be very, very soon, very, very soon. So you just have to be geared up, revise as much as you can.